Hello everyone, and in today's session, we'll be covering the introduction to machine learning topic. And basically, in this lecture, we'll be discussing what are some of the applications of machine learning, what exactly is machine learning going to be, some formal definitions, and we'll also be covering about something called as learning techniques, which are an essential part of any machine learning algorithm. So, the prerequisites for applying or knowing about machine learning in detail would be the basic libraries which we have covered in the previous sessions, that is the matplotlib, pandas, and numpy. And building on from that, we will be also using some library known as the scikit-learn that we'll be using here in machine learning. So that is one extra library which we will be needing to use when applying any machine learning model. So yeah, the prerequisite for this is the basic Python libraries, and secondly, it also involves some basic mathematics or statistical knowledge that also needs to be very strong when applying or when knowing some how the algorithm works basically, right? So but in this lecture we'll be covering about what exactly is machine learning, what are the types of the learning techniques, and what are the applications of it in real life. So moving on to the formal definition of machine learning, right? So before I write it down, there's an actually a picture or a picture of a set that basically describes how or what machine learning is basically. So it is actually a subset of artificial intelligence. So machine learning is actually a subset of artificial intelligence that basically enables a computer to learn, right? The literal meaning of it is machine learning, right? You're making the machine learn something. So basically it is nothing but a subset of artificial intelligence that enables computers to learn. How it learns is it learns through history, right? It learns through some data, some previous data, and then it will make some decisions based on that previous data. So basically that is machine learning. It is not exactly a separate domain, it is a subset of artificial intelligence, so it will come under artificial intelligence, and it basically is nothing but making a machine learn or to predict something based on data, and that data is past data. To be more specific, the formal definition of machine learning is actually proposed by Arthur Samuel. So this is what the formal definition is, and it is almost available in every textbook. So what it basically says is it is the field of study. This is the field of study that gives computer the ability to learn without being programmed, right? So this is what is the basic definition of machine learning, right? It basically says, or Arthur Samuel proposed, that it is a field of study that gives the computer the ability to learn without being programmed. So you are trying to get an output without actually programming it. So you want an output just by feeding an input but not writing any logic to it. That is what the end user would want, right? He would want some prediction which he is not using probability or using some math to predict. He just wants the computer to predict by itself. So the job of us, that is the engineer or machine learning engineer or a data scientist, would be to make sure that we get the right prediction, and that right prediction will be done by applying various algorithms or various models. So till now what we have done or what we have covered is what is machine learning, and this is the formal definition, that it is a field of study that gives computers the ability to learn without being programmed, and this was proposed by Arthur Samuel, right? So then we also said that it is a subset of artificial intelligence. So it is a subset of artificial intelligence and not exactly a separate domain that enables computers to learn from data. So you are going to make some sort of prediction using previous data. Now the next question that would come to your mind is how, or how does a machine learn the previous data? So essentially, there are three types of learning techniques in any machine learning concept, right? In any model is related to these three techniques. So let me just write down those the learning techniques, basically how machine learning works, right? So essentially, there are three types of learning techniques. One is the supervised, right? Supervised learning, and the second one is unsupervised learning, and the third one is reinforcement learning, right? So so we basically looked at what is machine learning. Now we are going to look what the learning means in that, right? So how a machine learns is basically through these three techniques. So there's something called as supervised learning, there's something called as unsupervised learning, and then there's something called as reinforcement learning. So let us have a look at each of these learning techniques one by one to understand how you are going to approach any machine learning problem statement, because essentially your model is going to be one of these three categories, right? Either it will belong to a supervised learning technique or an unsupervised learning technique or a reinforcement learning. So basically what this supervised learning means is your model is going to be trained using some labeled data. Now I'm very sure most of you know what a data set is, how a data set looks like. It is nothing but rows and columns. There are something there is something called as features or attributes that we looked at feature in the feature engineering video. You have seen what are the features, what the info function does, and so on. So in supervised learning, there is going to be one feature which is already labeled. What that basically means is, maybe I can have a data set which has, or which is essentially a house price prediction. So in house price prediction, in my data set, in supervised learning, there will be a price column which will be depicting the price of the particular house. So using this already labeled data, we are going to create a model, or using supervised learning, we are going to create a model that will map this input and output and then make predictions on the new data which you provide. So since there is already existing data of the price of the house, and let's say some other features are the dimension of the house, the number of bedrooms, the size of the house totally, and then there's a price of the house. So using this existing data, what we are going to do is we are just going to feed maybe the size of the house, and then our model is going to predict the price of the house. So this is essentially what supervised learning means. So in supervised learning, there is going to be a labeled data, meaning the input will come with the corresponding correct output. There is already a correct output present in the data set, to be more specific. What we are going to do is we are just going to give an input, and using that history, our model is going to predict what the price of the house will be. So what are some of the algorithms that use this supervised learning is linear regression, decision trees, you have SVMs, support vector machines. So let me just write this down, what I just said. Let me just write that down. Supervised learning. So basically what I said is supervised learning is trained using labeled data. Trained using labeled data, right? So it is trained using labeled data. Input comes with corresponding correct output, right? So basically what an example of that, as I just said, is the house price prediction. It could also be some kind of a stock price prediction, or it could also be spam detection, right, in emails. So basically supervised learning is going to be used majorly in two cases, right? So what problem we're trying to solve in supervised learning is two. that is the regression problem and the classification problem, right? So in supervised learning, you're going to solve, or you're going to try to solve two problems, that is the regression problem and the classification problem. So regression problem deals with a prediction of some numerical aspect, right? So in terms of our house price prediction, the output is going to be a price, it is going to be a number, it is going to be a numerical value, right? And classification problem is going to classify and not predict some number, it is going to predict a yes or no kind of an output. So classic example of a classification problem is predict cancer detection. This essentially is a classification problem because you're going to either say yes cancer or no cancer, right? So it is going to be either malign or malignant, right, in case of a cancer. And in a regression problem, we are going to try to predict a value slash a number. So that is what we are going to do in regression problem, and this is what we are going to do in classification problem. So essentially we started with what is machine learning. We looked at how a machine learns, that is through these three techniques. Now we are looking at the first technique, that is supervised learning, and we got to know one thing, that supervised learning works on history, it works on labeled data. There has to be an existing feature which we are trying to predict already, and using that history our model is going to predict whatever input you are going to give. To make it more easy, you can maybe take another example. Maybe I have two cards, and one card is apple and another card is showing a picture of banana, and there's a 2-year or 4-year child sitting in front of me. What I essentially do is I show the apple card and I tell him this is apple, and I show a banana card and tell him this is banana. I keep on doing this for maybe 100 times. I keep on shouting this is apple, this is banana, this is apple, this is banana. What happens is after maybe 200 times, I just show him the picture of an apple and he himself has to tell that this is an apple. So basically this is how a supervised learning technique works. You're going to give a labeled data, and then after a point of time, using your algorithm or model, it is going to give an output based on the input, right? So this is how supervised learning works. Now the next type of learning technique is unsupervised learning. Right? A is missing here. Yeah. So basically, in unsupervised learning, you do not have any labeled data, right? So in the case of supervised learning, you had something called as a labeled data, but in unsupervised learning, you do not have any label, or you do not have anything which has that will help you to predict, right? So this model is basically given without explicit label, and what you're going to essentially find is you're going to find some hidden patterns from this. Since in supervised learning you explicitly have the corresponding target column, here also you will have, but not explicitly. You're going to find some patterns or structures to kind of support your claim. So some algorithms which are essential or used in unsupervised learning is the clustering algorithms. You're going to make use of clustering algorithms. Right? So in unsupervised learning, you're going to make use of clustering algorithms, and in supervised learning, you're going to make use of, okay, I didn't write the algorithms. Let me just write down algorithms used. So basically, you're going to use linear regression. You're going to use SVM, that is support vector machine. Then you're going to make use of decision trees, that also comes under supervised learning, right? So these are some of the algorithms that we'll be making use of. In this video we are just going to cover the more basic kind of things, and we're not going to dive into how an algorithm works, what is the math behind it, and how it is implemented. That will be done in the subsequent videos. Today's video we're just going to discuss the basic intro part. So then moving on, we are here, we are in unsupervised learning. So unsupervised learning, as we said, it is going to make use of clustering algorithms. And in unsupervised learning, you do not have any labels. So the data is without explicit label, and through your model you're going to find some hidden pattern or structures. So basically the algorithm, what it will do is it will create clusters, similar data points, and find some associations among the variables present, right? So it is going to find some kind of hidden pattern in that. So that is what unsupervised learning is basically going to do. So what are some of the applications, or where we'll be using unsupervised learning, is basically in anomaly detection and recommendation systems. So you would have seen in any OTT platform they will have some recommendations based on what you have seen before. So basically that recommendation system is nothing but it works behind, or the principle behind it is unsupervised learning. So let me just write down basically what it means. Is you're going to basically the model is given data without explicit labels, and you are going to find some patterns, right? So this is what you're going to do. Basically you're going to feed the model a data without any label and going to find some patterns from it. We looked at what algorithms you're going to use. We're going to use the clustering algorithms. So that is basically what unsupervised learning is, right? So the third major type is the reinforcement learning. This is a more advanced kind of a learning technique. So what is reinforcement learning, right? So what is the logic behind reinforcement learning is, this involves basically an agent. So here the concept of agent will come in, that will interact with an environment. So that will interact with environment and learn through reward and penalties. So that is what reinforcement learning is, right? So what are some of the algorithms that we are going to use in reinforcement learning? Is it will sound a bit complex, but once we start doing the basic supervised and unsupervised learning, this concept might become more simple to you or for you to understand. So some algorithms that we use are going to be Q-learning based algorithms, Q-learning, and some gradient methods, basically these are the algorithms that we'll be making use of in reinforcement learning. So basically what I just said in reinforcement learning is the agent. So basically it involves the concept of an agent, and that particular agent is going to interact with the environment and learn through reward and penalty. So essentially the machine is going to learn by experiencing. So maybe you have two people, person A and person B. When the machine goes to person A, let's say the person A slaps him, and when the machine goes to person B, the person B gives him something. He gives him a high five or a chocolate. So essentially what the machine will understand is that whenever I go to person A, he's slapping me. So it is understanding that it is not a good environment, it is a penalty. But when I go to person B, I'm getting rewarded by something. So this is how reinforcement learning is. The machine is learning by himself or itself, and not by some kind of history. It is learning by reward and penalty. So whenever it gets rewarded, it understands that this is a good environment, and whenever it gets a penalty, it understands that it is not a good environment. So it basically involves the concept of an agent. That agent will interact with environment and learn through the reward and penalty. So the agent will explore different strategies, right? So then it will accumulate the rewards over time, and then it will understand, or okay, this is a good environment and this is a bad environment. So reinforcement learning is is a more complex kind of a learning technique presently for you, since you don't have any knowledge about any of the learning techniques. So once you get started with supervised learning and then go into unsupervised learning, reinforcement learning might become more and more clear to you. So essentially these are the three learning techniques, or how any machine learning algorithm or can be classified into. So any model you apply is going to belong to one of these three techniques, right? So we looked at basically in the beginning what is machine learning. We also looked at how a machine learns, and that is through some learning techniques. Essentially there are three types of learning techniques: supervised learning, unsupervised learning, and reinforcement learning. And in supervised learning, you're going to have a trained data, you're going to have a labeled data. So you're going to train your model basic using labeled data. And in supervised learning, you're trying to solve two problems, that is the regression problem and the classification problem. In regression problem, you're going to predict a value, a number, and in classification problem, basically you're going to predict a not a number. It is going to be either a yes or no kind of answer. We are going to classify them as maybe cancerous or non-cancerous. So in terms of cancer, it is going to be malign and malignant. And some algorithms that are used, that is linear regression, the most basic one. Then we come into SVM, support vector machine, and the tree based algorithms such as decision trees. So these are some algorithms that we'll be making use of in supervised learning. Then we looked at what is unsupervised learning. So unsupervised learning is basically your model is given data without any label. In supervised you had labeled data, in unsupervised learning you do not have any labeled data. So what you're essentially going to do is your model is going to find some patterns, so or some kind of pattern, and then it will cluster it. So hence we are going to use clustering algorithms. So it will cluster the data into two halves, maybe yes or no. Even that case can come here in unsupervised learning, when maybe you don't have any labels. Then we looked at what reinforcement learning is. We understood that reinforcement learning, it involves the concept of an agent. So what that agent will do, that agent will interact with an environment. It understands through that, it will run through reward and penalty. If it finds an environment that is rewarding it, it will learn, okay, this is a good environment for me. And if it goes to an environment which is punishing or giving it a penalty, it will understand that this is a bad environment. So this, in reinforcement learning, the machine is trying to learn by itself by this concept of reward and penalty, right? So we also looked at these learning or basically the algorithms which are used for reinforcement learning, that is the gradient methods and the Q learning based algorithm, right? So essentially this is the introduction to machine learning part. We looked at learning techniques, we looked at the formal definition of machine learning. Now we will look at what are some of the applications of machine learning, right? So currently machine learning is a widely used kind of application. It is used almost everywhere. It is used in healthcare. It is widely used in healthcare nowadays for these various disease predictions and analyzing various graphs and images, or what we say scans. It is used in finance for fraud detection, since fraud kind of thing is going on very highly in India. It can be also used in fraud detection. It is also used in entertainment, as we came to know that the recommendation system is basically it uses the unsupervised learning technique. So your Netflix recommendation and YouTube recommendations, even machine learning is used there. Obviously it is also used in automobiles. Now recently you can see a lot of autonomous vehicles, so and your driver assistance systems. So all these are some of the applications of machine learning. You name it, it will be present in any kind of technical aspect. Also your voice assistants like chatbots, voice assistants like Alexa, all those things also use machine learning. So it's transforming the industry. It's the future. So basically, in this particular video we looked at all the basic intro to machine learning. What is it, what are applications. We also looked at this important part, what is a learning technique, what are the various type of learning techniques, and what are some algorithms that are present in each of these learning techniques, right? So I'll wrap it up over here. Thank you so much for watching.